In several examples of our travel agency, we see that the actors of reality are related in different ways. For example, when an attraction belongs to a category, and in turn, this category can be the category of many attractions. We've seen that when we design transactions, we can represent these relationships by including the attributes of one transaction in another. The agency's staff tells us that they work with suppliers who from time to time offer them visits to tourist attractions in different parts of the world. Each supplier offers many tourist attractions, but each attraction is managed by a single supplier. To represent this reality, we will create the supplier transaction where we will record suppliers. We select File, New, Object, and we call it Supplier, and we add these attributes: Supplier ID as identifier, supplier name to store the supplier's name, and supplier address to save its address. Using the transaction diagram object, let's take a look at the relationship between suppliers and attractions. We select New Object of diagram type, and we drag the attraction and supplier transactions from here to the diagram. Note that we haven't established any relationship between these two actors yet. We save. Since a tourist attraction has a single supplier that offers it, we will include the supplier identifier in the attraction transaction structure. To do this, we open this transaction, and we add the supplier ID attribute. We also add the supplier name attribute to be able to show the supplier's name in the attraction screen. We open the diagram again. Now there's an arrow whose simple head is pointing to supplier and whose double head is pointing to attraction. This indicates that an attraction has a single supplier and that a supplier can offer many attractions. To sum up, if we add the identifier attribute of a transaction to another transaction, which, as we've seen, will be a foreign key, a one-to-many relationship, also called one-to-n, will be established. In it, the many side of the relationship is where the foreign key is located. Now, if we examine the tables generated by GeneXus starting from the transaction design, we can see that based on the supplier transaction, a supplier table will be created with the same structure as the transaction. Based on the structure of the attraction transaction, GeneXus creates an attraction table with the following structure. If we compare the structure of the attraction table to that of the attraction transaction, we can see that the country name, category name, city name, and supplier name attributes are not included in the table because they are inferred attributes. As we've seen before, since they are in the extended table of the attraction table, their value can be retrieved from the tables where they are physically stored. This is the most common way to represent a one-to-many relationship between two actors of reality, that is to say, between two entities in our system. However, there are other cases of one-to-many relationships where we will use another type of representation. Remember flights, where one flight has many seats, and each seat is assigned to a flight. This is to say, a one-to-many relationship. We will open the flight transaction structure to see how to represent this relationship. In this case, seat is included as a second level of the flight transaction. So, how is this one-to-many relationship different from the one-to-many relationship that we saw between attractions and suppliers? Why is it that we don't represent both cases in the same way, with the same transaction design? Note that the existence of seats doesn't make sense unless they are in a flight. This is to say, it doesn't make sense to consider a seat without always relating it to the flight it belongs to. On the other hand, an attraction may not have a supplier that offers it, and it would nonetheless exist on its own. The other difference is that when we're entering the details of a flight, we're also entering the details of its seats. Just like when we enter an invoice with lines, all the information is entered at once. On the other hand, the suppliers and attractions details do not have to be entered all at the same time. An entity such as seats, which only makes sense if it's represented in relation to another entity, in this case flights, is called a weak entity. This type of weak one-to-n relationship is usually represented with a single two-level transaction, where the weak entity is in the second level. It's different from the one-to-n relationship of suppliers and attractions, where we created two transactions and set as foreign key the primary key of the other. The weak one-to-n relationship can also be represented with two transactions. It's exactly the same for data modeling purposes, where part of the primary key of the seats transaction is the flight ID attribute. More specifically, this attribute will be the foreign key of the flight table. And there lies the difference between a strong and a weak entity. Note that since flight ID is part of the primary key, it's not possible to set a flight seat, such as to a window, without giving a value to the flight ID. On the other hand, it is possible to enter an attraction here without indicating its supplier, if that attribute has the nullable property set to yes. Alright, so far, we've seen one-to-many relationships, but they don't always fit the reality that we want to represent. For example, suppose that the travel agency tells us that their reality has changed. Each supplier offers many tourist attractions as before, but each attraction can be managed by several suppliers, and not only one, as it has been the case until now. Which is to say, the relationship between suppliers and attraction is no longer one-to-many, but many-to-many. How do we represent this in GeneXus? The answer is by using two transactions, one for each entity. In addition, one of them is added as the second level of the other. This is done by taking into account the way in which data will be entered. For each supplier, all its tourist attractions will be entered, or for each attraction, all its suppliers will be entered. In this case, the agency has asked that users enter all the attractions of each supplier. We will now implement this in GeneXus. To do so, we open the attraction transaction, and we remove the supplier ID, and the supplier name attributes, and we save. Now, we open the supplier transaction, where we add a second level, and we add these attributes. Attraction ID. Note that when we type a primary key attribute that begins with attraction, the level name is automatically changed to attraction. Also, we add attraction name and attraction photo. Now let's see how this relationship looks by opening the diagram of the attraction and supplier transactions. Now, there's a double-headed arrow in each end of the relationship, which indicates that the relationship is many-to-many. That is to say, one attraction is offered by many suppliers, and one supplier offers many attractions. Let's take a look at the tables created by GeneXus based on the previous design. There's an attraction table, a supplier table, and a supplier attraction table. We create a new diagram object and drag the three tables to the diagram. Note that in this case, GeneXus creates a table for each transaction included in the many-to-many relationship, attraction and supplier, but it also creates a third table called supplier attraction to establish the relationship. Looking at the structure of this third table, we notice that only the identifier attributes of the other two tables are included. Therefore, every time that GeneXus establishes a many-to-many relationship, it will be represented in the database with three tables. One for each entity involved, and a third one with the identifiers of both tables. This third table may have its own attributes, such as, for example, the date in which the supplier started to offer that attraction. If we open the diagram again, We can see the attribute in the relationship table. The many-to-many relationship between attraction and supplier has been divided into two one-to-many relationships, using the supplier attraction table to establish the relationship between the previous ones. Finally, let's update our KB and GeneXus server. And we reorganize it to have the tables created. So far, we've seen that using transactions and their attributes, we can represent different relationships between the actors of our reality. In this course, we won't talk about one-to-one relationships. For example, when the travel agency needs to associate with each customer the bank account opened to pay for the services hired. We mentioned another scenario of one-to-one relationships when we talked before about subtypes. This was an example of specialization, when an entity is a particular case of another. If you're interested, you can explore these cases in our advanced material. Now, let's move on to the following topic: